Hello everyone, my name is Leviathan, and this here is the PNV-28. It is a 3D printable housing for an EP33 style Russian tube that is a Gen 1, of course, for 3D printable Gen 1 night vision housing, which I don't think any others exist, which is kind of neat. The PNV-28 name came because of the PNV-57, which we actually have the A variant of, and I do. And so it's fairly fun to play around with, but it is only Gen 0. And so I decided, well, I would like a helmet-mounted like Gen 1 night vision scope, because I'm too poor to afford anything else. And so I spent probably about $80 on the helmet setup of the J-arm, Rhino mount, and crappy airsoft helmet, and then the rest of it went into the monocular, and it cost about $200, which is more than I wanted it to. I was a little bit optimistic on the price, but about $200 will get you everything here, minus the patches, and I think the hot glue, and like the 9-volt and the 9-volt connector there, and like some of the wires. But like at that point, it's like small change. And so yeah, this is the PNV-57. You can see here I have it currently down, and that's because I have two different lens attachments for this thing at the moment. The first one is a M42 lens, and that is the Russian camera standard, at least I think it is. And they used the M42 lens for a bunch of different things, including the monocular for the lens for the NV100. This is the one that I took apart, the hollow shell of what used to be a night vision monocular. Now the tube and power supply are put onto this thing. And so you're gonna need an NV100 in order to put this together, at least for the power supply in the back here. This takes the NV100 power supply. You can have any EP33 style tube, should fit. I believe the spherical cathode should work, but I haven't looked at the engineering documents for it, or at least I don't remember it, and so I don't know. I will say with this smaller lens, I guess what I was trying to get at was that if I found it's a lot harder to line it up to be one-to-one with your eye, and so that's why you have this thing here which pulls the J-arm, which to be honest is pretty crappy. I think a dovetail mounting should work, but if you're doing this, you likely don't have the cash to spend about $200 on your mounting system. Like $100 for the J-arm and $100 for the mount itself. And then that's not even including the helmet and the rest of the stuff. And so if you're doing it cheap, this is likely how you're gonna do it. Unless you get like a Rhino 2. If you get a Rhino 2, no, that's still a little expensive. But yeah, this is like the cheapest of the cheap night vision mounting stuff I could get. Cost about $200. And that's why you have this wacky setup with the bungee cord going to the J-arm, going to all of the mounting stuff, is because this is set so that it's one-to-one with my eye. That's why I'm not going to take this up, because then I'm going to have to redo all the settings and try and get it dialed all back in, which is super annoying. But I guess a little bit of how this works. You have power supply back here, run off a 9-volt. I will say this power supply is usually run off of 3 volts, 3 volts from 2 AA's. I'm running it with 9 volts, and it has yet to explode. I've run it for maybe a couple hours. At least, I would say at least like 45 minutes. Probably more, but I haven't like actually timed myself, and so I don't really know the true specs of how long I've run it for. But I think this power supply seems to take the 9 volts fairly well. And then you have the 2 high voltage outs from the power supply coming out and then getting put in the tube. This front one here is for the photocathode. You'll see that in the assembly video. No, this is for the photocathode. This is for the phosphor screen. And so this is negative, this is positive. And so it uses a voltage multiplier. I know the name, but it's hard for me to say for some reason. And so There is a real shocking hazard here. It is partially DC, and by the fact that technically, electronically speaking, I guess you could say ground is at 0 volts, despite the fact that electrons flow from negative to positive. I don't know, I've always found it weird that you have the electronical drawings going from positive to negative into the negative to positive, but whatever. So you have technically 0 volts at the negative side, and you're gonna have probably close to 18 kilovolts on the positive side, which would make a direct current, except the voltage multiplier has it to where it oscillates up and down, so that it can multiply the voltage. And so there is technically an AC component in there, but it is not 1800 kilovolts AC. It is a certain unknown amount of AC with a DC offset, if that makes any sense for anyone who actually knows electronics, which I am a beginner in. But yeah, this thing uses a C-mount, at least the current one that I have is a C-mount lens, a 1.8 50 millimeter lens, a focal length lens, with a microscope eyepiece, 22 millimeters, 22 millimeter wide eyepiece, and then the tube in there. The math works out on this because the tube itself, it expands it out, it unzooms it, I guess you could say, by about 1/2. And so whenever you do the math, it's a 1-to-1 conversion between these two optics, which is fairly good. And I have the assembly video, or at least assembly cuts of everything, which I'll put together. But I think that's mostly it. Supplies, you're gonna need mounting hardware, of course, helmet, J-arm, mount, all that jazz. You're gonna need your 3D printer, some filament. There's an M3, you need M3 heat set insert screws or something with similar dimensions. You need M3 screws or whatever you chose that had similar dimensions to the heat set insert holes. And so you're gonna need those. You're gonna need a, I forgot the name of it. I'll put it up in the video here, I guess, but it's the screw for the camera, like J-arm thumb screw. It's your standard camera mount, and so you probably have it on like a webcam or like a camcorder. There's probably a little hole, so yeah, you can mount like a bunch of random stuff to your J-arm because they use that screw for it. You're going to need high voltage cabling. This is Belden 8866 number 18 wire, at least that's what the eBay listing said, rated for 40 kilovolts, which is way more than this thing really uses. And so you're going to want to get high voltage cabling. Spark plug cabling may work, but this hole is meant for this wire, and so spark plug cabling might be a bit thick, and so you might need to like widen that hole out with like a drill or something. And I guess same with the input hole there. You're gonna need hot glue, some Velcro to stick on the power supply here. Of course, the lenses and the eyepieces and the NV-100 monocular. If there's anything else I missed, you can probably look in the document that's gonna have all the stuff you need to buy for this thing. But yeah, I think that's most of the information on this thing. I think it works fairly well. It's really hard to get this thing on camera. Like it does have a pincushion distortion to it, which is a little annoying. But like you can see some faint stars that you can't see with your other eye, and you can see a little bit better with this monocular than you can with a human eye, which is really, really cool. But it's not Gen 2 or Gen 3 night vision. This is like bottom of the barrel, probably equivalent to your regular Gen 1 stuff. I would use a flashlight with this thing. I would use a flashlight on this thing. I have yet to test it on a full moon, so we'll see what it looks like with that. But some people say that's kind of cheating. But yeah, I haven't tested it with a full moon yet. But I think it's fairly cool. $200 for analog night vision. It's not digital Yahoo, but it's still probably on par with digital stuff, just because it's old Russian tech. But yeah, I'm fairly glad with how this came out. I guess I will segue you to whatever part is next. I have no clue. It's probably the build segment, but I could be completely wrong. Actually, no, I am wrong. You're gonna see the performance of this thing. Back when I had the M42 lens on, because I'm too lazy to get new footage. But yeah, you're gonna see some performance of this thing, and then you'll see how to build this thing once you've decided for yourself whether or not you actually want to build this. All right, so everyone, this is what the night vision looks like without, or at least what my phone sees, without any night vision on. It's just what the phone sees. And I'm looking through the night vision without any infrared IR illumination. I don't know exactly how focused any of this is, but hopefully it'll focus on that light there. And so this is without any IR illumination. All right, you can kind of see the window out there. And then this is with infrared illumination. So as you guys can probably see, this is similar to the PNV-27, where it is an active night vision unit. You really do need an IR floodlight to be able to use this thing. So yeah. I don't know how well you can see out of this thing. I don't know how focused it is, but I guess we'll see. So, I hope you guys liked the demonstrations I'd shown off for this thing. I think, like, it amplifies light, at least my description of how I see through it. Like, it amplifies light just a little bit to where you can barely make out stuff that you couldn't with your naked eye. But it's no Gen 2 or Gen 3. It's not like it turns night to day. It's just relatively simple light amplification. I would not be surprised if there are digital systems that do better than this in terms of the resolution of the tube itself compared to a digital screen and all that stuff. And I said I would use this, like, you don't have to use an illuminator with it. I would recommend it. Using an IR illuminator on there. You don't technically have to, but yeah. So I will say I would recommend a counterweight because this power supply is not enough for the actual tube itself, or for the weight of this thing. Like, if I were to, let me see if I can pull off a little bit of a demonstration here, but with my finger kind of right here, it is, if I were to put it up here, it's definitely very front heavy. I don't have a counterweight on there because I spent more than I thought I would on this, and so I didn't leave any room in the budget for any sort of counterweight, and I'm too lazy to make one myself. It's usable without a counterweight, and it's still definitely fun to run around with. I would recommend getting one. I don't really know where you'd put it, considering you have to put the power supply at the back. Maybe just like make your own pouches or something and stick them kind of in between. If you were to move the 9-volt maybe up here or something, there's some things you can get away with that. But yeah, aside from counterweight, which is probably needed, I will say that this eyepiece, don't expect, I don't know how well you can see it, and I don't want to flip it up. I'll probably get an image of what the eyepiece itself looks like. But the phosphor screen is not blown up to be the complete eyepiece, so you're going to have the phosphor screen and then some of the glass around the tube, which is fine. Like, it zooms it in enough to where it's not like a tiny little speck, especially with the original eyepiece on this thing, it was tiny, and so the eyepiece here definitely does help with the zoom. If someone, I'm not an optics person, I don't know a whole lot about how that all works, and so if someone else wanted to 3D print a back mounting option for this that has a better option that'll blow up the screen to be big, to take a more of the field of view, that'd be great. It would sacrifice resolution though, which is an issue, especially with these crappier Russian tubes. But yeah, so aside from the counterweight, I think that's about it. And I hope you guys have made a decision on whether or not you want to make this. I'll have the build guide there. The stuff that I bought for this will be linked in the description and probably like a Google document or like a notes. It'll be somewhere in the description. If not there, then it's going to be, you're able to download it from the actual 3D printable files itself. Yeah, so I will say, one thing I remembered is this computer, this switch for the back here, the power switch, I just tore out of a random computer power supply. I don't know where you buy those. I assume you can probably buy these for cheap, but that's what I designed this thing off of. If you want to go with something else, then you can totally do that. It's just an on-off switch. You can wire up whatever you want. And so, yeah, I guess I'll hand you guys off to the building clips. Hello everyone, and welcome to the assembly guide of the PNV-28. So this is, of course, putting a Gen 1 Russian monocular into a 3D printed housing that I made. Hopefully when I put it together, it'll all work. But yeah. So the first thing you're gonna want to do, aside from acquiring the monocular and taking it apart, getting the tube and power supply out, and then 3D printing the parts, is you're going to want to put in the heat set inserts. You got some over here. These are M3 inserts that are 4 millimeters by 5 millimeters, and then these are the inserts for the J-arm attachment, which is this little ring over here, which is going to slide over there. And so pretty much you're gonna want to have these two things. If you can't find M3, I made a mistake living in America. It's a little harder to come across the M3 screws, and so that was a bit of a mistake on my part. So if you can find something that is in imperial units but has the same dimensions, then it'll probably fit in the holes. And so yeah, so first things first, you can kind of see the heat set inserts on that side. There's some on the other side for the lens attachment. There are the heat set inserts in the power supply here. You can see the switch. This is just an old switch I pulled out of a computer or a computer power supply. And so I just kind of jammed it in there. You can probably make do with something else. So yeah, I don't have an Amazon link for that or anything because I just tore it out of a PC. But yeah, so first thing you're going to want to do, aside from all that other stuff, is probably prepare the power supply. This is the first time I've done any of this stuff, and so it's kind of like it's kind of anxiety inducing because I think I know what I'm doing, but am I completely sure on everything? So that's all fun. But yeah, so power supply here, you have a little lid for it and the couple screws that hold it in place. And so now for the scary part, because I got to cut this so I can stick this in there and then wire the wires through here. All right, I'm gonna cut this thing. Let's hope I totally didn't just screw up the project. All right, here's a monocular with the wire in there. Tiny little thing, actually. That might be a pain to solder to, but I bet I can find a way. And here's the power supply itself. I'm just gonna like double check that this thing actually fits in here and make sure I don't have to reprint anything. That would be nice. Let's find out. All right, I know you probably can't see this. I'm holding it too high, but okay, pushing this thing in here. I think it's fairly flush with this thing. And I'm just gonna dump all the screws out here because that's not super important. That fits through there pretty well. I can kind of move it over, screw this thing in place. And of course you have these other wires, which these two are ground wires. And so I'm gonna solder these two together and then from there solder this Belden wire on here. I'll put the name up on screen of the wire, but it handles high voltage, and so I'm going to solder that to here. I'm going to solder the wire onto there and have it lead out from here. So while this thing's in here, I don't think it's going to need a whole lot of insulation, but this thing, I have a 3D, or I haven't designed it yet. I'm going to do that very quickly. But I'm going to design a part that'll bridge the gap between the two with just plastic, and I don't have any epoxy, so I'm just going to use hot glue and hope it works. But yeah, so I'll bridge that, and then we'll have that go over to here, which I'm gonna bridge between there and there. So I'll get back to you once I've soldered everything. All right, so you can see kind of the little wire extension there. That's where the little heat shrink tubing is, at least not on the main wire, but on the like smaller wire. And then you have the heat shrink on the main wire, which I couldn't get it connected through like soldered, but this little part there is metal, and so that's going to bridge the gap between here and this wire. And so yeah, this thing should now close up easily. Let me, if I can just put this thing up on here in a minute. All right, so I have hot glued that in place, and it'll turn on and off. And then I also put a crimp on here. I don't have any more like singular ones. All of these that I have are already attached to a wire, so I just put a double on there, which isn't great, but it works, I guess. And so yeah, I also printed out these things. The quality of this one really isn't great. There are a lot of stringing and stuff, but it's just a little cover for the wire, which is fine. I don't know why the print quality is so bad, but yeah, so this sits over this wire here, and I'm gonna solder this wire to it. And then once I solder this wire to there, I will lift that up and then use the hot glue gun to secure that in place. All right, so this little thing has been glued in place, and so after that, I think I'm gonna put the Velcro on the back of this thing, and I don't have the helmet with me, but I'm gonna put some of the adhesive Velcro onto the back of the power supply, and stick it on the back of the helmet, and then cut these things to the length that they're gonna be needed to be at, and then yeah, and then we're gonna get this thing ready. And of course I dropped something. All right, so you can see my little helmet set up here, and here's the power supply on the back with two little wires that'll be hooked up to the AA power supply over there. But these wires go up. I have this little patch, and so I just kind of routed the wires over it. I'll likely just replace that with the Velcro strap, but for now it's fine. And so you can see these wires are a bit long. I could have kind of tried to measure it, but, well, yeah, measuring it with a string probably would have been better instead of cutting it while the wires are attached. I might be able to get the lengths of these wires before, so I can tell you what I cut them as. But really, I will say, I'm gonna adjust this forward. I'm gonna put that, probably the J-arm just right there, and see how long I think these wires need to be, and then I'll cut them accordingly. So yeah, that's it so far. All right, so the metal plate that I used kind of caused some problems, and so I got some stripped down wire, and I soldered it to the tip of there, and we're gonna see, whenever I insert the tube, I'm gonna kind of coil it around the little entrance here and see how much contact I can get it, and we're gonna see if this works. All right, so I've taken kind of a different approach actually. I've taken this small piece of like stripped 22 gauge wire, and I wrapped it around the front, and I'm holding it in place with some aluminum tape. Now this tape isn't conductive, but the outer rings here are, and so I'm hoping that the tape will keep it in place, and that when I charge it up, it'll connect with the photocathode, grounding it and giving me power. All right, so you've just seen all of the build clips that I had gotten. I'm not great at getting all of the build clips finished, so I'll kind of, or at least when I was filming it, I didn't film everything, as you can probably tell. And so I'll kind of finish off some of the other stuff. Hopefully I remember everything. If I don't, there will be another clip after this video of me, after editing the entire thing, going out and clarifying some stuff. But this wire here was soldered onto the switch because this internal yellow wire was soldered to the switch, and so this just hooks up here. This 9-volt has a piece of Velcro on it. There's a strip of Velcro on the back of this power supply. Of course, I think I already said in the video to put all the heat set inserts in. If you don't know how to do that, you kind of just grab your soldering iron and you stick it in the heat set insert and wait for it to heat up. You don't want it to stick past the heat set insert. You can probably just look it up, to be honest, better than I can explain it. And I'm too lazy to put a video together to show you guys. But yeah, I think I showed the assembly of this thing fairly well. For the optics on the front here, so I think the video cuts out whenever I put the tape in there. So you want to cut the tape to where it'll kind of like, so you want to be able to tape it to the actual plastic itself. At least that's how I have it. But in order to keep the tube, well, actually, sorry, no. Before you solder any of this stuff in place, you want to put this little, the ring for holding this monocular in place. So this is probably the first thing you'd want to do before, not before like putting in the heat set inserts, but before starting to attach all the electronics, is you want to attach this little ring with that thumb screw goes into, and you want to put the heat set insert into that. Once you do that, all right, then I would solder, or not, yeah, then I would solder all the photocathode and this stuff together, because now you can't remove this without breaking it. I could remodel it to use to be like a hinge. The main thing is I ran out of screws, and so I wanted to originally make this 2 screws, but I ran out of screws, and so I made it 1 screw, and I don't want to have to go out and buy more screws. I could, it's like $3, doesn't super matter. But this, you have to slide on first. You're gonna hear some plastic cracking. It's fine. And if you mess it up, you can just bend it and out of there. And if you really wanted to, you could redesign, because this thing's pretty crappy, to be honest. It probably should be redesigned. I'm too lazy, and it works. So if it doesn't work for you, then you can redesign it. It's not that hard of a piece to redesign. But yeah, once you get this ring on, I wouldn't solder this cable, the positive end, which goes into this little cap here. I wouldn't solder this till the end. So once you put this on, I would put together the 22 gauge wire that's wrapped around here with the tape, and then I would put the back shim in. That's something I forget. I have a bunch of 3D prints here, but I don't think I have a failed back shim, and so I don't have that to show to you, I don't believe, which is a shame. But there's a little back shim that once you slide the tube in place, you put the back shim in, and it's flush with the back of this thing. It's just to make sure that the tube doesn't wiggle around. But I put that in, and then I would screw on the back of here. This thing should just screw onto the threads there. It's a little tight, I think. I think it was a tight fit for this eyepiece, but I didn't super care. Especially, again, it works. Why? If it ain't broke, don't fix it, as they say. And so, yeah, pretty much it's just, once you have the back shim in there, screw this on so then the tube can't fall out. And then once you do that, I would screw on this little front piece here, and then I wouldn't put the lens on yet. I guess that's the same with this. I would not put the eyepiece on yet. I do those as like the last 2 things, because then I would solder this thing in place. This wire, I would put it in with a little wire protector there, and I would put that all in place, and then I would screw the optics on. And then you put it on your J-arm and get it figured out how you want to, on whether it's your right eye or left eye. I will say, you cannot easily swap eyes with this because of these wires. If I were to swap the eyes, these wires would have to go like through here. And so really you gotta take off the J-arm. I'm not gonna do that here, but you have to take off the J-arm, rotate this thing so that the arm is on like this side, and then you'd mount it, and then you can get it on the left eye. It's not too bad, to be honest, but yeah, I'm not sure if I'm missing anything on the assembly here. Should be fairly straightforward. And if I miss anything, I don't think it'll be too hard to figure out what you're supposed to do. I'm probably already going to say this, but print the this lens piece, I believe, was 102%. This one, I think, was 101, maybe. And so you're going to want to print those at those percentages because the actual file for it is scaled down by 2% because the threading is super weird in Fusion 360. And so on my printer, it wouldn't thread correctly if I didn't scale it up. Like the threads would be too small. And so you're gonna have to scale the prints up. But aside from that, I think that's really it. And so, yeah, I think we'll go ahead and get into, I think that's really it. Well, I hope you guys liked this review / tutorial of the PNV-28. I am glad with how it turned out and how it all works, especially since this is the first time I've actually 3D printed something of value, I guess you could say. Like all my other prints are just, oh, I need like a little plastic piece to make this work. One of the old night vision monoculars, I printed out a battery cap for it. And the battery cap's garbage. It like almost doesn't work, but it does. And so like this is really the first 3D printed thing I've made that like actually works and it's not bad and like it all fits. And so I'm fairly glad with how this turns out. Hopefully the Russian tolerances aren't bad and all the tubes are similar to this tube in size, because if they aren't, then that's gonna suck because then it's only gonna work on my tube and then like what's the point, right? But yeah, I'm fairly glad with how this turned out. And I hope that if you decide to build one for yourself, you are glad about how well your monocular turns out. And so yeah, thank you for watching this video. Thank you for I guess deciding that you want to build this thing. And I hope you enjoy your monocular.